Sir Justin. Good day. So before we start, I first introduce myself. My name is Chakri or Sabia, and right now let's all discuss our topic, which is the Rosette pattern, the freeze pattern, and the tessellations. So these three patterns are basically what are our part or what is the topic we all discussed. So first is allow me to explain what is the Rosette pattern, which is my part actually. So what is pattern? This is a type of symmetrical designs formed by repeating motifs arranged around a central point. These patterns exhibit finite asymmetry, meaning their symmetries are limited. The rotation and or reflections around central point without trends. So basically, these symmetrical groups have all been one of two types, which is the cyclic symmetry group and dihedral symmetry group. So, what is these two types of symmetry groups? So, let's all discuss what is cyclic symmetry group. Alright, so cyclic symmetry group only consists of rotation, okay? And that has an order, and that's group is what we call CN. So basically, cyclic symmetry group is only has rotation reflection. I mean rotation group order that consists of CN. So while the dihedral symmetry group in continuation has rotation symmetry and also the reflection lines, and the group is called DN. So basically, what is the definition or the difference between the cyclic symmetry group and the dihedral group? So basically, cyclic only consists of rotation, while the dihedral symmetry group was consists of a rotation and also the reflection. So that is the difference between the cyclic and the dihedral. So in conclusion, here in the book, cyclic and dihedral symmetry groups are known as a Rosette symmetry groups, which these two symmetry groups are included in Rosette pattern. And a pattern with Rosette symmetry is known as Rosette pattern, which is the topic, right? So patterns have been used as architectural and sculptural decoration of the new century. So basically, this pattern really not just because about how it will really consist on the on what they have, but also really the important thing. Alright, so right now let's all discuss the second pattern, which is the freeze pattern. So what is a freeze pattern? These also known as a border pattern or an infinite strip pattern, refers to an endless strip featuring repetitive design. The term frieze originated from architecture, specifically denoting an decorative carving or pattern positioned horizontally beneath a roof line or ceiling. These presented below are several instances of frieze patterns. The pattern repeated and extend infinitely in both directions. So let's watch this. Continuation, a frieze group represents the collection of symmetries associated with a frieze pattern. These symmetries are geometric transformations formed by rigid motions and reflections that maintain the pattern's structure. The group's comprise translation and potentially includes glide reflections along strips along axis, reflections along the streets narrow the axis, and 180 Celsius rotations. So that's it in my part. Thank you.
Hello everyone, this is Sashami. I'm Faha. I won't be showing my face because I look so pale because I'm sick, but I will discuss the last part of our reporting, which is the tessellations. A tessellation is defined as a pattern of shapes that covers a plane without any gaps or overlaps. Tessellation can be found on pavements, patios, and wallpapers. Tiled surfaces of floorings and walls is an example of tessellation where there are no tiles which overlaps and there are no gaps between shapes. In most cases, tessellations are found by repeated patterns. However, some utilizes pictures or designs which no way repeats. Examples of tessellations of regular polygons are the following: tessellation of triangles, the tessellation of squares, and the tessellations of hexagon. Looking at these three examples of tessellations, the squares can easily line up with each other, which the triangles and hexagons involve translation. So the vertex point is the point where the shapes comes together. The sum of all the angles of each shape that comes together at the vertex point is 360 degrees. The shape will overlap if the sum is greater than 360. Otherwise, there will be gaps if the sum is less than 360 degrees. Naming tessellations can be done by looking at one vertex point. Looking around a vertex point, start with a shape with the least amount of sides. Count the numbers of sides of each shape at each vertex point. The name of the tessellation then becomes these numbers. Example in tessellation of triangles. The number of sides is 3 and there are 6 shapes. Therefore, it can be named as 3, 3, 3, 3, 3, 3. For the squares, it can be labeled as 4, 4, 4, 4. And for the hexagon, you can call it 6, 6, 6. Semi-regular tessellations can be formed using a variety of regular polygons, and the arrangement of these polygons at vertex is identical. So here's examples of semi-regular tessellations. So as you can see, there are 3 triangles and 2 squares. So the name is 3, 3, 3, 4, 4. Look at the next one. The next one has 3 triangles and 2 squares also. So the name is also 3, 3, 3, 4, 4. The next one has 1 triangle, 2 squares, and 1 hexagon. So the name is 3, 4, 4, 6.
Tessellation is a pattern of shapes that covers a surface with no gaps or overlaps. Geometric transformations made using translation, slide, rotation, turn, and reflection, flip. Regular tessellations use one shape only: triangles, square, and hexagons. Vertex point and naming a vertex is where a corners meet. If angles sum to 360 degrees, they tessellate. Naming uses the number of sides around vertex. Semi-regular tessellations combine 2 or more shapes. Art and artists, used by Moritz Cornelis, Esther, and Bruce Bilney in artworks. Real-life uses, seen in tiles, floors, walls, pavements, and decorations.